It's your unit exam. Okay. I'm going to show you two methods today for solving these type of questions. So one is using the product law, and then I'm going to show you with implicit differentiation. Okay, so method one, it says find the derivative at a specific point. That's easy. So using product law, y prime. Okay. Yeah, it's part 2. 8.4 part 2, sorry. Okay, so here's an example, right? If we rewrite this equation, it's x squared times x squared minus 4 to the 1/2.
Is it before or after the area and integration?
It's right before. So we are on page, what page are we at?
I'll find it now.
Page 12, chapter 8. Okay. All right, product law, derivative of the first is. Can you all derive this, please? You know how. So use product law and derive this. Okay? Thank you. Okay, so where are you getting stuck? So we all got this point, the first line? Yeah. And then we can factor out an x. Choose cancel here. We can factor out an x. And the smallest power is x squared minus 4 to the power of negative 1/2. So you factor that out, you're left with the 2 still left over here. Because we have 1/2 minus negative 1/2, it's equal to 1. And then this guy's gone. All we have is the x squared left over. Yeah? This guy? Why? We factor an x, but it's a positive exponent. So we just put the negative to the bottom. Yeah. Thank you. So then this would be a square. Yeah. Thank you. Okay, so this is going to become, on the numerator, 27 minus 8 is 19. 19 times 3, 57. Thank you. Now, the bottom we have 9 minus 4 is root 5. Or, if we rationalize this, it's 57. Does it say to 2 decimal places? Can we do this? Let's go to 2 decimal places. What does that equal? 25.49. Already? Okay, so that's the old school way. I'm going to show you a new way today using logs. So if left side equals right side, then the log of the left side equals the log of the right side. But we're going to use natural logs. Okay, so here we have, if I have method 2, if we know y is equal to x squared times x squared minus 4 to the half, I believe. Okay, if those left equals right, then we can say, therefore, the natural log of the left equals the natural log of the right. Well, why would I want to do that? Well, we could use implicit differentiation, and we can also use our log laws to make this look a lot prettier. So we can split up this guy. Yeah, so we can make this natural log of y equals, what happens here? Which rule? You can. It's not as nice of a derivative, though. Natural log of, so we're going to use which law here? The one where product law? So it becomes natural log of x squared plus the natural log of x squared minus 4 to the half. Right? The product rule. Could we do another rule? Take the half out. The power law, we can take this guy and move him to the front. This square, no. Oh, yeah. Thank you. So 2 natural log x plus 1/2 natural log. Let's make that nicer. X squared minus 4. Now, there's no rules for addition and subtraction inside of a log, so we'd have to stop there. Okay? So now let's implicitly derive this guy. Okay? So, what is the derivative of the natural log of y? 1 over y times y prime. Good. Equals, what's the derivative of 2 natural log x? It would be 2 times, what's the 2 over, it becomes 2 over x. So it's 2 times 1 over x. Now, derivative of natural log of x is 1 over x. Plus half times, what's the derivative of the natural log of x squared minus 4? So 1 over the inside times the derivative of the inside, which is 2x. What happens here? The 2's cancel. Okay. So what we can do here is I want y prime by itself. How do I get rid of y? Multiply it to the other side. So what we have is y times 2 over x plus x over x squared minus 4. We're just finding the derivative at a specific point, so I don't have to spend time simplifying this. Could we just plug in our point now? Yeah, our point was 3 and 9 root 5. Yeah. And we already know the y value, so instead of we don't have to plug 3 in to the original, we already know the y value. So y prime at this point would then be, what's y? 9 root 5 times 2 over x is 3 plus 3 over 3 squared minus 4, which is 5. Which also gives us what? The same thing as above. Okay, so although the solutions look very different, they are the same thing. It's just another method to get the derivative. If we actually subbed in the actual equation of y and then rearranged everything, we get to the same point. Well, I don't know, which you have to decide that. I don't know. I think there's more room for error in the first. But. Okay. So why don't we try this guy? Okay, so can I write a little note? Is that okay? In order to use the product rule, it would have to be applied in 3 parts. Okay, so if you have 3 things multiplied together, then the derivative of, say, u times v times w, what do you think the derivative would be? Okay, derivative times u times v times w plus u times v prime times w plus u v w prime. Yeah. Pretty. If we did that for this function, it would be huge, right? Yeah. It'd be gross. So instead, in this case, logarithmic differentiation would be so much easier. So let's do it that way. Sorry, product law. Okay, is easier. So what would we do with this guy original guy? Logify them? So if m equals n, then the natural log of m equals the natural log of n. So what would this become? Natural log of y equals natural log of x times, let's make this a fraction right off the bat, 3x plus 1 to the half and x minus 5 to a half. Could we use some laws in here? Ooh, that's not the right bracket. Yeah. Okay, so rewrite this out and expand it as much as you possibly can. Wow, you guys are fast. Okay, so 2 people are done. So expand this as much as you possibly can. Okay, so use the product law.
But then we're just doing 3 things again.
It's a lot easier though, right? It's going to be a lot prettier than this because the derivative of a natural log is 1 over the natural log. This is way easier. I can prove it to you after if you want me to do this on the board later.
No, I know, but
so this, it becomes natural log of x plus natural log of 3x plus 1 to the half plus natural log. Okay, and then one step further, what did you do here? Yeah? Bring down the exponents. So natural log of y goes natural log of x plus 1/2 natural log of 3x plus 1 plus 1/2 natural log of x minus 5. So now can we derive this? Yes, way prettier. May not look that much prettier, but as terms of deriving this, way prettier. No, we haven't derived yet. We just simplified it. Okay, so derivative of natural log of y. 1 over y, because 1 over the inside, times the derivative of the inside, y prime, or y prime over y. Yeah. Derivative of natural log over x. 1 over x plus 1/2 times 1 over 3x plus 1 times what? 3. So let's put the 3 on top. The derivative of the inside. Okay, Greg? So after we take 1 over this, we have to multiply by the derivative of the inside. Plus, we have a 1/2 in front, times, what's the derivative of natural log of x minus 5? And what's the derivative of the inside there? 1. Okay. So So now we move the y over. So y prime is equal to y times 1 over x plus, you can write this as 3 over 2 times 3x plus 1 plus 1 over 2 times x minus 5. Done. It's not so bad. No. Okay, because if you were to derive something like this, it's most likely to find what it equals at a specific point. All right, so applications of exponents. That was on your quiz. So we're not doing that one. But I'd like you to go on and try number 2. It was in your homework. It was in your homework. So let's, yeah, it might show up. It might show up. Okay, find the equation of the tangent line to the curve at x equals 0. So in order to know the equation of a tangent line, that's using y minus y1 equals m times x minus x1, meaning you need 2 things. What are the 2 things you're going to need? Slope and a point, your y value. So could we figure out slope first? Yet? How would we find slope? Nope. Derivatives. Okay, y prime. Yes. Yeah. Okay, so, when we plug in x equals 0 to get the point. But we're getting slope first, so we'll get to the point. So worrying about slope, so deriving e to the power of negative x is equal to what? So it's e to the power of negative x times the derivative of the exponent, which is the negative 1, which I put in front. Right? Derivative of e to the u is equal to e to the u times du dx. Or u prime. Yeah? No. No. Because it's an exponential function, which is different than just a x squared, for example. Plus, what's the derivative of e to the power of 2x? E to the 2x times 2. Derivative of the exponent was 2. Okay, so at x equals 0, what's our y prime equal to? E to the negative e to the power of negative 0 plus 2 times e to the power of 2 times 0, which gives us 1 plus 2, or 1. And that represents what? Right, y prime always, from the 2nd unit to the 8th unit, it's not changing. No, no. So that's our slope. Okay, our point. Well, we have the equation for y equals 2x. So at x equals 0, what's y? So y would be equal to e to the power of negative 0 plus e to the power of 2 times 0. Remember, anything to the exponent of 0 is what? 1. So we get 1 plus 1, 2. No, we gotta have it together. Sorry. Okay, we know our slope, we know our point. Easy from here on out. So we get x minus y plus 2. Should you be able to do that in your sleep? That y minus y1. So, let's take what we've learned in logs and apply it to curve sketching. Turn the page. Or actually, it's on your next page. It's right there. You okay, Craig?
Sure.
What's wrong? Tired?
He's just piling stress.
Yeah. Yeah. Stress? Yes, there is. Assignment? Oh, no, there's no activity in this unit. In order for us to fit it in, there's no room for an activity. Okay, discuss the intervals of increase, decrease, max, min, concavity, and inflection point. Okay. So let's go ahead and try this. Let's start with increase. How do we get increase, decrease? How do we get increase, decrease? Y prime. Okay. Y prime equals derivative of e to the u is e to the u times u prime. So in this case, derivative of e to the negative x squared is e to the negative x squared times negative 2x. It's kind of ugly. So what are our critical values? Just 0 because of this x right there. What about, are there any critical values for our exponent? No, you could put anything in for exponent. Positive, negatives, zeros. Okay, so zeros are only 1, so we're going to test it. And just this negative 2x is the only thing that's affecting it. So if I put a negative number in, it becomes negative times negative, give you a positive, so that's increasing. And if you put a positive in, negative times positive, be negative, decreasing. So at this point, you'd still have to state increasing from negative infinity to 0, decreasing 0 to infinity. And do we have a max or a min? Local max at, because they're going whoop, x equals 0. And when x is 0, what's y? 1. So 0, 1. That was easy. Now, concavity. How do we get that? Very ugly derivative. Well, we can use product rule. All right, we have to derive this guy. So y double prime, derivative of negative 2x. Derivative of negative, guys, negative 2. And then leave the other guy. Plus, leave the negative 2x. So I'll actually leave this as a minus. And derivative of e to the power of negative x squared. Well, that's the same as our original. So that's going to become negative 2x e to the negative x squared. Okay, what do we have to do with this guy? Simplified, I guess. So plus 4x squared e to the negative x squared. What would you have to do here? Factor. What can we factor out? A 2. What else? Do you want to factor out a negative 2? Sure. Let's do negative 2. And e to the power of negative x squared. So 1, we're factoring out a negative, so it's actually become 1 minus 2 and an x squared. Because this one didn't have an x, and this guy has an x squared. Okay, so critical values, we can also go like this guy, negative 2 e to the x squared. So bring that negative x squared down. What are my critical values? 0. Okay, 0. Okay, let's start at the denominator. Is there anything we could put in our exponent that would give us 0? No. Okay, so there's no critical values there. How about this? Can we make a 0 on our numerator? Plus or minus 1 over root 2. Right, how would we get that? Well, you could just go ahead and set that equal to 0. And then divide. And then square root both sides. One. Kind of an ugly guy. Not going to lie. Yeah. Negative 1 over root 2, positive 1 over root 2. Okay, critical test, boys. Critical value. What's a number less than negative 1 over root 2? A little smaller. Negative 10. Sure, we can work with negative 10. So negative 10, so you'd have a negative because of the negative 2 times. If I had negative 10 in here, what's this inside going to be? A negative. All over, bottom will always be. Doesn't matter if we have a negative exponent, it's still going to be positive. Yeah. So that gives us what there? Oh, thanks. Cool. Okay. Positive. Okay, it's supposed to be lemonade, but I don't know what. I know, right? The color? It's a little off. I know, she's so nice. Okay. Wish I taught English. 0. Try 0. Negative. What would this give you? Positive. All over positive, so negative here. And then last, so we'd have a negative times, if this is positive 10, still negative, all over a positive, it's a positive. Up, down, up. A frog. Okay, so we have to state concave up when? There. Negative infinity to negative 1 over root 2. Union. 1 over root 2 to infinity. Concave down. Okay, could you expect a written response like this? Heck yes. Yeah. Oh yeah. So while we're not done, what do we still need? Inflection points. So we have 2 inflection points. One of them's at f of negative 1 over root 2, and one's at 1 over root 2. Where do we go to get the y values? The original function. So plugging in negative 1 over root 2, if I have negative 1 over root 2 squared, what does it become? Positive 1 over 2. So we have negative 1/2. E to the negative 1/2 is the same thing as 1 over root e. Oops, I guess that shouldn't be in brackets. Okay, if you put in a positive 1 over root 2, it's going to be the same thing, so 1 over root e. So what I'd like you to do, I'm going to pause the video, and I want you to do the exact same thing with letter B, and then we'll go through it. Here, want it? Okay, you can have it. We find y prime. Okay, guys, listen up. So first derivative is going to tell us increase or decrease. Right away, because you have a natural log, you know the domain is x is greater than 0. Okay, so here, when you derive, guys, listen up. Jonas, even if you have it, just relax and listen. We could also write this as 2 natural log x all over x. So we ask ourselves, our critical values are, what makes something a critical value? What would make the denominator 0, or what would make the numerator 0? So could we put any value of x that would give us a 0? Natural log. Like if I put in 1, Yeah, plug in 1. What's natural log of 1? It's 0. So that's a critical value. Oh. Yeah. And is there any values here that would give you a 0? Just 0 itself, which we have. So we have 0 and 1. But 0 doesn't exist. You're right. It's a critical value. If the graph did exist to the left, it would still be a critical value. Even if it doesn't right? If the graph looked like this, there wasn't, the domain was XER, whatever makes your numerator 0 and denominator 0 is a critical value. It's a point where the graph can change from increase to decrease, by definition. Okay, so in here, we want to test between 0 and a half, or 0 and 1. Okay, so looking at this, if I did half, natural log of 1/2, what would that give you? A negative number. So a negative over natural log 1/2 on the bottom is a positive number. So here it's actually negative. Well, the reason why is e to the power of a negative would give you a fraction. So whenever you have the inside between 0 and 1, it gives a negative. Okay? Think of it this way. If you know a natural log function looks like this, the x-intercept is usually 1, right? So between 0 and 1, it's a negative y value. Greater than 1, it's a positive y value. Right? You saw that before? Yeah, okay. All right, so now if I plug in 2, for natural log of 2, it would give me a positive over a positive. So this is positive. So we are decreasing the increasing. So you should state decreasing 0 to 1. What type of brackets are we using? All round. Yeah. And increasing 1 to infinity. Pretty much, yeah. All right, we also have a max or a min. Local min at 1. So 1 comma something. We have to plug it into the original equation. 0, 1 comma 0. Okay. Now, second derivative. Did you guys use product law or did you use quotient? Who used product? Who used quotient? Wow. Okay, so it really doesn't matter. And it's kind of 50-50 in the room. Let's use quotient because a bunch of you use product. We should get the same answer in the end. Okay, theoretically, derivative of the top. What's the derivative of 2 natural log x? Well, it would be 2 over x times the bottom. So what's going to happen here? Just becomes 2 minus, leave the top. What's the derivative of x? 1. All over x the bottom squared. So we're left with 2 minus 2 natural log x over x squared. What can we do with this before we can actually take out the 2? 1 minus natural log x. So quotient law is probably a lot prettier than if you did products, because you'd have to actually factor out the x to the negative 2 as well as the 2. Critical values, what would make my numerator 0? Well, what would make this 1? Because 1 minus 1 would give me 0. Natural log of what equals 1? No. E. E. You're getting there. Natural log of e is 1. What would make the denominator equal to 0? 0. Again, where does our graph start? Starts at 0. And it's e because natural log of e is equal to 1, and 1 minus 1 would give you 0. All right. Give me a number between 0 and e. 1. Yes, 1. Okay? What's the natural log of 1? 0. 1 minus 0 would give you a, excuse me, gentlemen. Landon. Natural log of 1 is 0, right? So, and 1 minus 0 is still a positive. So we have a positive on the numerator all over. 1 squared would also be positive. So we have a positive here, or concave up. Okay, a bit number bigger than E. 10, sure. Natural log of 1 minus the natural log of 10 would be what? Positive or a negative? A negative over a positive, which gives you a negative. So you should have had concave up from 0 to E, concave down from E to infinity. Do we have an inflection point? Yeah. Inflection point at f of E, which equals, where would I get that? The original to get the actual point. So natural log of E is 1. 1 squared is 1. You can do it. Okay, so your homework's there. We have 2 pages, 6, 7, 9AB, 5, 9, 13A. I mean, technically we could draw it based on what we'd actually have to figure out intercepts and all that good stuff. I'm pretty sure that your unit exam does not have any drawings. It's only like find the max and min, find concave up, down, find inflection point. Yeah. Okay.